Hello and welcome back to Cracking the Cryptic and another of the Sudoku Professor Richard Stolk's incredible SVS Sudoku variant series. He's got up to 315 different variants, which is like an answer to the person yesterday who asked how many variants of Sudoku can there be? And Rich, the answer is lots, which is not just because it's written backwards in Richard's name. Now, somebody else in the comments pointed out that I hadn't been putting up the rules in large enough type, so hopefully we're doing that now, and my apologies for that. Paul, you don't need to apologize for any irritability. I wasn't really noticing any, and good luck. Now, what's going on in this puzzle? Well, I'm going to go through the rules quickly. It's fairly easy to state this rule, but maybe we can use an example to understand it. Normal Sudoku rules apply. Clues outside the grid indicate the maximum sum of a group of connected ascending digits from that side in that row or column. So Richard included an example, which is like this. If you look from the left here, 4, 9 is the biggest sum you can get to from ascending digits. There is a longer one, 1, 2, 3, 5, but that only adds up to 11, whereas the 4, 9 adds up to 13. So that's the clue on the left. From the right, again, there's 1, 6, 7, but that only adds up to 14, whereas the 8, 9 at the start, looking from the right, adds up to 17. So I thought maybe let's have a quick look at Chain Bear's animation that we were using for Skyscraper Sudoku yesterday. And if we look at this, which highlights so if we had a row of 2, 4, 5, 1, 3, 7, 9, 6, 8. Now Chain Bear was animating this from the point of view of Skyscraper Sudoku. But for this puzzle, the longest or the largest sequence of ascending digits is the 1, 3, 7, 9, which adds up to 20. So the clue from the left would be 20, I believe. 6, 8 adds up to 14, which is actually the second largest sequence. 2, 4, 5, a paltry 11 from that side. And then if we run on the animation and look from the right-hand side of this row, what do we get? We get 8. Then 6, 9 adds up to 15. I think that's going to be the clue. The only other ascending sequence is 1, 5. So 15 would be the clue there. So that's how that's how it works. I'll have a go at the grid in a moment. I do want to mention Patreon, where Simon's Solve of Sisyphus has been up for a couple of days and is really entertaining. Do have a look at that. It's Fistamerfel's latest logic puzzle. Brilliant puzzle. And also Demono's solution videos there. And tomorrow we're going to put up my crossword world record attempt. That might be worth looking at as well. Won't be a very long video either way, I hope. We'll see. Now, as far as other things go, of course there's the apps and something going on Discord at the moment. Do have a look at that if you get the chance. But anyway, let's have a look at this puzzle. Do try it on the link below the video. I'm going to give it a go now. Let's get cracking. Where do we start? Oh, look, big clues, 36. So the numbers not in the 36 ascending sum add up to 9, and that's because of a little known fact that the numbers from 1 to 9 add up to 45. What do you mean you knew it? Impressive, impressive. Anyway, so the numbers not in the 36 add up to 9, but they could be up to 3 cells, one end or both ends. Could only be one cell. Yes, it could go 9 at the top, and then 1, 2, 3, 4, 5, 6, 7, 8, which would be a sum of 36. But these 3 cells will always be in this sum. I don't know how helpful that is. Let's try the low clue, 9 here. Oh, of course. Well, 9, yeah, right. Yes, the simple question is, where does 9 go in the row? And if it goes in any of those cells, the number before it is forming a sequence that makes more than 9. That's so neat. So I can get my first digit, put a 9 in there. Because otherwise there must be a sequence that adds up to at least 10. And the 10 here, it's the same question from the other side. What goes before a digit goes in here, and if it was anything more than 1, we'd have a number more than 10 there, because this would be a sequence adding up to at least 11. Oh, this is lovely. This is going to go for the whole row. That's absolutely gorgeous. Right, where does 8 go in the row? Can't go in any of those cells, because whatever comes before it, looking from this side, would make that more than 9. So 8 has to go here. Now what goes in this cell to keep that down to 10? A 2. Where does 7 go? Not in any of those. Same reason. This is beautiful. That is absolute class in a glass from Richard there. Just from those 2 clues, you can fill in the whole row. Madness. I love it. Now, how can we use that further? Right, we know these 3 clues are, these 3 cells are in this 36 ascending sequence. Yes. Yes, we do. And I don't think we can avoid having this cell in the sequence. If we did, if these 3 were, as I suggested, outside the sequence and added up to 9, well, that's not going to work, because one of them would then have to be 7, 8, or 9. And even 7 would need 2 1s to make 9. So these 3 are all in the sequence. These are, in fact, if those are in the sequence and they're ascending from 6, they must be 7, 8, 9. That adds up to 30. We need another 6, which is either 2 cells or 3. So if it's 2 cells, it's either 2, 4 or 1, 5. And if it's 3, it's 1, 2, 3. I can't really put that 1 in there like that. I'm going to put it in as a corner mark because I don't know if that's needed at all. I can't get much else out of that. Let's have a look at this 33 now. Now, 33 has to be at least 5 cells, so this central cell is in. Is the 7 in? Does the 7 have to be in the sequence? The only way it's not is if the sequence starts here and goes down the bottom of the grid. But then it would have to be 5 cells that add up to 33 without a 7, and the most that 5 cells without a 7 can add up to is 98654 is 32. So no. No, no, no. The 7 cannot escape from the sum. It must be part of it. So is this cell in the sum? If this was 9, 7, 654 is the absolute maximum you could achieve if this cell wasn't in the sum, and that is not 97654. How much is that? 22, 31. It's well short. Right, so this cell is in the sum. So that is a 9 and that's an 8. That's 24. We need another 9. Again, it can be in 2 cells or 3, and there are lots of possibilities that I'm not going to fill in. Now what? 12? This is going to have to be a 1 to avoid this pair going over 12. Oops. 1. And this can't be 4. Oh, let's have a look at this 24 clue. Yes. Can the 7 be in the 24 clue? The answer is no, because the only bigger number than the 7 here can be a 9. You can't keep extending it. And the sequence would have to begin here and end here, and the maximum it could be is 22. So the 7 is not in it. The 8, is that definitely in it? Yes, it is, because this number must be smaller than the 8. It's 4, 5, or 6. So if that's got to be in it, and it has, because the number can't be 7, 8, 9 here because of those, Therefore, that's in it. And now the 8's in the sum in this row. I don't think this can be as small as 5, because then you'd get 432 at a max, which is only 22. So that is a 6. Does this have to be a 5 in the same way? We've got 10 more to do. Could be 2, 3, 5. But it could be... No, it couldn't be 2 cells, because 5, 4 is the most you could do. So it is 2, 3, 5. And that sum, I mean, that is the sum making 24. 2, 3, 5, 6, 8. So that's done. So I'm going to take out that colouring. Now we've got a 4, 7, 6. There we can fill in 4 and 5 in the central box. 1, 9 pair over here. 2, 3 pair there, but now look at the 12 clue. This can't go 2, 3, 8, because that would make 13 already. So 3, 2, 8, 1, 9. We haven't achieved the 12 sum yet. 5, 7 would work, and does work, because you can't make 12 using 4, 6, and 7. So look, most of boxes 4, 5, and 6 already done. I mean, it's brilliant how this works together, but it's finding the next clue. So this 12, let's have a look at that. It's quite small. 2, 9 can't be part of it, because that makes 11, can't be extended either way. I suppose 4, 8, 5, 7 can go anywhere. No, I don't know what to do there. 24 clue. That could be 7, 8, 9 here, probably is, and then the other digits disposed below it, but it could also start there. How about this 20 clue at the bottom? Ah, yeah, that is interesting. 5, 8 can't be in it, because although you could extend them 1, that would make 22. These 3, the maximum they can be is 4, 6, 9, which adds up to 19. So they're not in the sum. The maximum these 3 could be are 4, 6, 9 again. So they can't be the whole sum. So this 7's in it is indeed the last number in it. All of these are in it. This is going to have to be a 6. Because otherwise it would have to come down to a 4, and that wouldn't leave enough space. These two, 13 from 20, they add up to 7, and they don't include a 6 or a 5. So we know they're 4 and 3. That is amazing. I love the way this rule works when I spot what to do. 1, 2, and 9 there. Ah, so this isn't 7, 8, 9 up here. I was wrong about that. So I think the sum must start here. Yes, it can't be 7, 8, 9 here, or that would join on in ascending order. So the sum starts here, goes down to there, and no further. And I know that because there's a 2 up here and a 2 there. So the 2 in column 8 clearly can't be in this ascending sum after a 3. Look, there's also a 9. So that's got to go in one of these two and must be at the end of the ascending sum. So 13... we need 11 more from these two. Can't go 6, 5 because they wouldn't be ascending. That is beautiful. 4, 7. That's a 6. So that one's done. We've got 5, 8, 5, 6, 8 triple there. 3, 4, 7 there. Ah, yeah. 1, 5, 8 down here. Okay, where's the 12? It can't be made up of 3, 4, and 7, so it's not up here. It doesn't include those, we worked that out. It can't include the 8, it's got to be 1, 5, 6 to make the 12. Yeah, that's fine. 8 there. Now, these won't go 3, 4, 7, because that would bust it. We mustn't forget the sort of negative constraint here. 3, 4, 7 in that order would make 14. Yes, this can't be a 9, because it would add on to the 5, 8 and make 22, which would break the 20 that we've already achieved. So 9 is not in that cell. Now what? Now we have to go across again, or use this 22? Ah, okay, the 3 can't be in this 22 because it would either end at the 3 if that was a 1, but if that's a 9, it would be 3, 9 and no more than 1 or 2 before, so that's not enough. So that's not in it. And it can't be 6, 7, 9 here because of that 9. So, I was going to say it could be 6, 7, 9 here, but that would then join on to the 5. So the 5 is in the clue. It can't go all the way because 5, 6, 7, 8 adds up to 26. But it must go there. So those are in it, and maybe this is a 1. So these 3 add up to 21 or 22. So these 2 add up to 16 or 17. So they've got a 9 at the top. And that fixes this by Sudoku. And now this by the sum again. That's beautiful. Bounces back and forth between them. We get a 7 there. These colours are all done. Used up, I mean. 4 or 6 at the bottom. That 9 has placed a 9 over here. Also given us a 1, 2 pair. Now, what were these able to be? These were going to add up to 9 in either 2 or 3 cells. So if it's 2 cells, it's either 3, 6 or 4, 5. If it's 3 cells, well, it's not 1, 2, 6 anymore because that can't be a 2 because of the pair. Could be 1, 3, 5. And it could be 2, 3, 4. That's annoying. Okay, fair enough. So this 16, can I use that? 10, obviously not involved. The 4 there. Actually, the 4's not involved because the next digit would have to be a 7. And then no bigger digits possible after that. So the 4's not involved. So it's confined to these 6 cells. This one is 2, 3 or 5. That's 2, 3, 5 or 6. 3, 7 or 8 there. 1, 9, 4, 3, 7, 5, 2, 6 or 8 there. So we've used 15 of the 45 total. We've got 16 to go in the sum and 14 not to go in it. No, we haven't used 15. We've used 14 there. 16 to go in the sum and 15 not to go in it. With 15 not in it could be 8 and 7. So the sum could be 2, 3, 5, 6. Actually, could it though? 2, 3, 5, 6 doesn't fit there because of the 2. Doesn't fit there because of the 3. Ooh, it could fit there. No, it can't, because that would have to be 8 or 7, and it can't be. So it's not 2, 3, 5, 6. That's interesting. So it's a 3-cell sum making 16. That can't be in it now, I think, because the only way you get... It can't end in the 5 if it's a 3-cell ascending sum. Oh, it could begin with that. That can't be in the middle, though. So the sum could be there, or it could be there. That can't be in the middle because 3, 5, 8, I think, is the only way to do that with a 5 in the middle. 3 is too low, and it can't be a 3 there because of that. Yes, right, so the sum is either there or there in 3 cells. And in 3 cells, it's either 2, 6, 8, 3, 5, 8, or 3, 6, 7. 2, 5, 8, or 3, 6, 8, or 3, 6, 7. I can't seem to rule any of those out at all. That's very irritating. Right, there's an X-wing on 9s in those cells. 7s in one of those 2. Okay, that's interesting. So if that's a 7, this would be the 3, 5, 8 combination to get to the 16. But if that's a 7, the 7 could be there. Oh, it would have to be there. No, it would have to be there if that was the combination. 3, 6, 7. But the combination could be there. 3, 5, 8. Ah, that's not quite the way. That is 2 or 8. Just by everything it can see. Oh, it feels so close here. What's going on now? 2 has to be in one of those cells. No, it doesn't. It can be there. That's nonsense. Right, let's think more logically. What can we do at this point? Maybe I have to work on these and this 17, which is so unappealing. Could be 1, 7, 9 if that was a 1. If that was a 1, there must be possibilities here. Oh, irritating. Right, let's think again. I can't see what to do. That's not a 7, I can see that. Right, let's try again down here. We're in either the grey or the blue. So if the blue was 3, 5, 8, which it would... It could be 2, 6, 8, but actually that would break on those two cells, so it can't be. So if the blue is the right sum, it's 3, 5, 8. 2. That's probably the right answer because it does seem to work. 4. You can almost fill everything in if that's right. What about here then? Does one of these break? 3, 6, 7 or 3, 5, 8? 3, 5, 8 would have a 2 here. No, I'm missing some way of looking at this that would be more helpful. What is there? What is there here? Have I missed something that would break another clue? We had 1, 3, 4, 7, 9. No, 5, 6, 8's got nothing to do with that. Now, whatever this is, 1 or 2, it's going to... If this was 1, 2, 3, that would go 1, 2. This then couldn't start with a 1. That's fine. How about if this went 1, 3, 5? I can't see what the next step is. Come on, Mark. Come on, persevere now. 9, 7, 5, 1, 3. That is 2, 4, 6 or 8, which is hardly interesting. Right, where is the 17 sum? Does it end in the 9 here? If it did, then there'd be 8 before it. That can't be a 1. So the 8 couldn't be 2, 6 or 3, 5. It would be 1, 7, 9 if that 9 was in it. Now, if it's not, which of these cells could be? Well, it would have to stop by here. And this can't be very high. It can only be a 6 at the maximum. 6, 5, 11. Oh, I just can't see how this works. I've got a feeling I'm very close to it, but not there. Right, let's have a go at these again. It must be in this 16 clue. 1, 4, 3, 2, 8. 3, 5, 8 there would put a 2 here. Ah, the 5 there would 3, 5, 8 with a 2. I can't see what if that does something clear to these, the top parts here. 6, 7, 8, 9. If that's 2, 4, maybe that's the way to look at it. The 1 would have to be down here if that's 2, 4, so as not to break up the sequence, or not to add to the sequence is what I mean. That would be 3 or 5. I cannot see what that's telling me. 9, 6, 7, 5, 9, 2, 4, 6, 7, 5. 1, 3 or 8 there, that's not very interesting. 1, 4 or 5 here, I thought I'd put that in before I hadn't. Right, let's try the effect here again of, can't be 2, 6, 8 because of those, so it could be 3, 5, 8. That would put a 1 here. 3, 5, 8. That would put a 4 here. That would make this 1, 5 with a 2 at the top. 3, 5, 8. 1, 4, 2, 6, 7. Ah, okay, it doesn't work. If this is 3, 5, 8. 1 there. 4 there. No, maybe it does 1, 5 at the top. That's very irritating. It could work. I can't see what's wrong with that. Richard, what am I meant to do? Tell me. Or you, dear viewer. How do you know what to do here? 9, 2, 4, 7. Maybe it is with the 17. Maybe 179 does work and must work, therefore. But it's quite surprising. If it's not 179, then it has to rise but in 3 or 4 of those digits. Oh, where's the 1 if it's not there? It's in one of these 2 cells. Oh, that's getting a bit more interesting. So then what happens if the 1 isn't here? It's in one of these 2 cells. How can we get to the 17? We need 4 cells, so it would have to go 1. This can't be a 2 because of that. 3. Oh, this one has to be at least 5. Yeah, you can't go 1, 2, and 2 more cells because then you'll hit the 9 as well. That's no good. So this is going to be at least 5 if it's not a 179 combination. Then, that can't be 5 and this 6. Yes, this breaks badly. Brilliant. My goodness, this is hard to see. Okay. So if this was up at 5 or higher, this would have to be 6, but then there's no fill there. So that isn't going to happen. So this sum doesn't run into a 5 or higher here. Wait, could it be 3 cells here? Or even 4? Then it would have to start 2, 3. And then this is going to be 5 or 6, and there's no fill here. Oh my goodness. So everything is impossible in these 4 or 5 cells, and it has to be 179 at the top. That is not easy to see. If that is actually the path here, Richard, that's very hard. Okay, but we're there now. Quite proud of that. Right, 179 here. That is the sum. So we mustn't, well, we probably can't go higher than that now. Now, the 1 there must join in the sum coming down here. So that's 135. That can't be a 5, and also it can't have a 1 there now, so it must be a 2, 4 pair. Whew! The relief. That's 3 or 5. So the 1 in the column is at the bottom We can put 1 in that box as well. That's not a 7. Still don't know where we're going in the bottom section here, but let's not worry about that for now. 1, 3, 5, 7, 4 can go in that box. Oh, that does become a 1 and a 2. 5, 6, 8 still to go in those 2 cells. That's become a 3 now. 2, 4, I don't know about the 3 and the 5 yet in column 3. That's not a 4, so 4 is in one of these 2. 2, 4, 6 at the bottom of column 5, so yes, that is helpful, because now that can't be a 2 anymore, given that triple. So this is a 3. That's a 5. Now we know the sum is not in the blue. It is, the 16 sum is clearly in the grey and is clearly 3, 6, 7. That is finishing everything off now. Let's believe the logic that we've done here. 6 there. 2, 8 pair left here. That makes this a 4. That's a 3. It's all working. I'm feeling happy about this. Right, that's a 6. We've got 9 and 2 to put in. That's an 8 to finish the box. 6. 1 there. It's, I was going to take out the colouring, but that is absolute frivolity at this point. No need to do that. 5 there. 8 and 5. 3 and 6. Let's see if we get a tick. It all looks like it works according to normal Sudoku rules, which the tick checks. But let's just see if we've got the sums right. So 1, 7, 9, 17. Yeah, the 10 was where we started. There's 4 versions of it. 12 is 5, 7. The 9, 5 versions of that. The 24 goes 2, 3, 5, 6, 8. That is 24, just confirming that. 3, 6, 7 is the 16, and that's only 13. Yes. 1, 5, 7, 9 there. 2, 4, 6, 7, 8, 9. That is right. 1, 3, 5, 7, 8, 9. Yes. The 24 is 1, 3, 4, 7, 9. The 20 is 3, 4, 6, 7. And the 12 was 1, 5, 6. My word, that's a tough puzzle. Oh, I'm quite surprised to see that's only taken me just over half an hour. It felt like a lot longer. Really interesting logic there, especially 2/3 of the way through. That stuff in the top row. Do let me know in the comments if there was something much more obvious to see. I'd be fascinated. And there could well have been. Maybe it was just easier to see that it couldn't be in these cells than I was finding it. Brilliant stuff. Thank you very much to Richard for mentioning that puzzle to us. Thank you for following the channel as always. Do hit the like button if you're enjoying the content, and the subscribe button, of course, as well. See you soon on the channel. Bye for now.